Here's your Precal 9.2.1 lecture part 2. We left off on, we did 9-95A, so now this is 9-95B. It says, use the idea of multiplying a matrix by a column vector to write the matrix associated with the linear transformation that takes V from 1, 0 to 4, 5, and W from 0, 1 to negative 2, negative 3. So I wrote all that down right here. So I'm trying to find a transformation vector, like a transformation matrix that's going to move 1, 0 and turn it into 4, 5. So I would like a nice matrix. We found out, I think we found out in letter A, that this number controls what happens to the with the x's, and this number down here controls what happens with the y's. But I mean, just in case we don't really know that for sure, we're going to actually do a little system of equations on here and see what the matrix is. So, so what were we supposed to be? So, yeah. Okay, so we're just going to find the matrix. So we're going to go, I'm going to multiply A times 1 plus B times 0 equals 4. Remember, because this is row 1, column 1. So row 1, column 1. So A times 1 plus B times 0 equals 4. So that's A plus 0 equals 4. So I know A equals 4. And I'm going to do it again over here. C times 1 plus D times 0 equals 5. So C equals 5, basically, right? So now I know what numbers, I know some numbers. Let's go ahead and find out. It also has to move, W has to go from 0, 1 to negative 2, to negative 2, 3. So I also need this to happen. So I'm going to check, I'm just going to keep doing the system of equations. So this is row 1, column 1. This is my row matrix and my column matrix. So A times 0 is 0, plus B times 1 is B. So B equals negative 2. And you might be seeing a pattern here by now. C times 0 plus D times 1 is equal to negative 3. So D is negative 3. So I don't know if you... So I just put all these numbers in here where they go. Like A was top left, B is B, C goes down here, and D goes down here. So this is a matrix that would move vector 1 from 1, 0 to 4, 5, and it would also move 0, 1 to negative 2, 3. So that was just a cute little game that they wanted you to play so that you can find out about the rotation and reflection vectors. And I'm going to kind of move a little faster through this because these are just things that back in the olden days we would just we would just give you these vectors and tell you to memorize them or write them down somewhere and use them. But in the same way that we did this, you could go through the long way and figure out the reflection matrices and the rotation matrices. I'll go through maybe one of them with you, and then the rest of them I am gonna just hand them to you. I'm gonna say here. So like in other words, without knowing how to derive it this way, I mean you can always derive it this way, but you could just write this down in your little cheat sheet book, and you can use that to reflect stuff. This matrix ends up reflecting any ordered pair or any vector across the y-axis. And I have these all written down in my little secret magic book here. So what's that? Why is there something under there? Secret one's under there too. So I'll show you how I got this one, and then I think I'll just have you write down the rest of them. Or, I mean, you can go through on your own and see if you can figure them out. So 9-96 says if the vectors 1, 0, and 0, 1 are reflected across the y-axis, what are the image vectors? So I just like to draw them and see what they look like. So if it's 1, 0, it would be like just pointing right here, and it would just be on this axis. And if I tried to reflect it across the y-axis, well, then it would be over here. It would just move over to there. So it would just, and that would be -1, 0. So I just wrote what would happen to them if I reflected them across the y-axis. 0, 1 would look like this. And if I reflected it across the y-axis, it wouldn't move. It would just stay the same. So I'm going to do kind of the same thing I just did in the last problem. I'm going to set up a transformation matrix. I don't know what the numbers are yet, but I know that when what I want it to do is when I multiply it by 1, 0, I want to get -1, 0. So I just do the same thing. This is row 1, column 1. So a times 1 plus b times 0. A is -1. Okay. C times 1 plus D times 0 equals 0. So C must be 0. And, I mean, we're doing this the long way. 0 plus B equals 0, so B is 0. And then 0 plus D equals 1, so D equals 1. And then, so then I just put them in the matrix, and then there they are. And you might by now be noticing this always does something to the x. It moves the x around, and this one moves the y. And so I'm going to give you the rest of the matrices that are important. They're probably going to show up in a math notes box up ahead too. But if you want to reflect over the y-axis, then you use this one. This one reflects over the x-axis. It turns out that you can do rotations. So if you do want to go ahead and look through 9-97, it kind of walks you around how to do rotations. But basically, if you want to go like a counterclockwise rotation by a certain amount of degrees, you can use this amazing transformation matrix. So this will give you a clockwise rotation. Like if you want to move your vector 60 degrees counterclockwise, you just stick in the numbers for 60 degrees. Like cosine of 60, put that in there. It's something root something, or sine 60, like that. Put all the numbers in there, and then multiply it by your vector, and it'll give you the vector after it's been rotated however many degrees you said. Okay, so you can try it. You guys are big kids. You can go in here, try this. Give me some questions if you have questions about it. Probably going to be a math notes box on it, and of course you'll have homework questions so you can try it out. Good luck.